always like to put my fraction in there. 0.52 times 0.48 divided by 1505. So our standard error is about 0.013. We're going to divide that by 0.03, or 0.03 divided by that. And I get my z star to be 2.329. Okay. Now what? How do I go from the z star to the confidence level? Well, I know that the confidence level is a midway round, right? And I know that the z star 2.329 is here, which means that what's over here if we know symmetric properties about the normal curve? Negative 2.329. Would you agree with that? You with me so far? Normal curves are symmetric. If I know the positive z value, symmetrically I can find the other. Aren't we looking for the middle as our confidence level? So what we would do here is we would do normal CDF, lower bound, upper bound. Because they are z-scores, our mean and standard deviation are just simply 1. So our normal, negative 2.329, to our positive 2.329. 0 and 1 is our standard deviation and mean. So what do you think? What's the confidence level? 98%. We went backwards that time, didn't we? Okay. We had to know some things about the normal curve. We had to know its symmetric properties. We had to know that what information can we extract from the problem. I thought that was difficult, but doable. Did anybody get it on their own out of curiosity? You did, Hunter? Come on, up top. You want a dum-dum? All right, come on, let's do it. You want to pick your flavor? Go ahead, just hold the desk here. All right, so any other questions about confidence intervals? Yes, fine. Okay. Not that I don't believe you, but I want proof.
Wait, what else did you put in dorm?
I know.
You got the z-score. You didn't go all the way. He's lying. He didn't do it. You can have it. It's fine. Yes?
What else did you put in normal CDF?
I did the lower bound, the upper bound, and then because these are z-scores, the mean is 0 and the standard deviation is 1. Okay? I think you could probably see something like that again. Quiz maybe, or a test maybe. I'm not saying guaranteed Friday, but it's going to happen again. I like it. Erica, get a dum-dum. Get some sugar in your system. You're tired. All right. Pass it around. Let's have dum-dums for everybody. It's like Oprah. Snow day for you. Snow day for you. Dum-dum for you. Why not? You know exactly what that means. You've seen it. All right. I'm glad somebody gets my sense of humor. Okay. So, hypothesis testing. Did you guys keep your data from the conversation hearts from last class? Yeah. Why not? All right, here we go. So last class we talked about, at the end of class, we talked about the 5 steps for a hypothesis test. And we're going to actually come back to that. And we're going to do some hypothesis testing today. We know what confidence intervals do. Okay? They let us estimate a population parameter from a sample. If we're trying to guess approximately between what and what is actually happening, a confidence interval is what we want. It gives us an actual estimate. Do you agree? Okay? Is it between? Does it capture 50%? Is it, between what and what approximately people are going to pass this amendment? That kind of thing. So it actually gives us an estimate. That's pretty important because if you're asked for an estimate That is your clue. That's a key word that tells me I need to find a confidence interval. On a quiz or a test, and even on the AP exam, it might not always say create a confidence interval. It might say create an estimate. That would be a confidence interval. Okay? Now, what hypothesis testing does that's a little bit different is that we actually are going to conduct a test on a claim. Okay? So, for example, if we claim, back to the conversation hearts from last class, we claim that 30% or whatever, what did I say it was, 10%? I forget. Yeah. 10%. 10% of those conversation hearts were pink. That's a claim out there. We can conduct a test to either prove it or disprove it. Okay? We're either going to say support, we should say not prove or disprove, support or contradict the claim. Okay? So those are two different things. Both are within inference, okay, this big ball of inference. Confidence intervals let us create kind of an estimate, and hypothesis testing, we have to have a claim to prove, to give evidence to or not. Okay? So let's review for a minute before we get to that, what the 5 steps that I told you were. So you should have had those written down before. Okay? What were they? State the test and the hypotheses, it should say. We're gonna get to that in a minute. Okay? The test right now, because we're dealing with proportions, is going to be a 1 proportion z-test. So you're always, and remember I showed you in the calculator last class, there's lots of different tests, okay? So it's going to be pretty important to tell me which test you're going to be using, okay? For now, the only one we know is the 1 proportion z-test. We'll deal with the hypotheses in a minute, but the null hypothesis is abbreviated HO, hence, oh. And the alternative hypothesis is abbreviated HA. Oh, hey, ha, whatever. So every time I hear the Lumineer song, ho, hey, I always think of ho, ha. So that's what we're going to hear one more time, just because I want to. Okay? It'll be stuck in your head forever, and you will love me for it, maybe. Okay? So, think of the null hypothesis, alternative hypothesis, null, alternative, null, alternative. Okay? I hate to say the word ho and ha, but you get the idea. The null and the alternative hypotheses. Okay? And we'll get back to what those are and what we need to write them for, or how we need to write them in a couple of minutes. Okay? The second step of the hypothesis testing, what was it? Conditions. And we know for proportions right now what the condition should be. Do you agree? Okay. There are 3 of them, 4 proportions for the 1 proportion z-test. They're the same as the 1 proportion z-interval that we did with the confidence interval. And they are 1, make sure that the sample was collected randomly. That the sample, well, the independence, which we rarely can prove, so we usually say that the sample size is less than 10% of the population. So I'll just write 10% condition. Don't ever write that and expect to get credit. Like you would have to use the context, right? 256 is less than 10% of all dum-dums, whatever, okay? Number 3, third condition. Yeah, NP is greater than 10. Sometimes we have to use P hat here. And then Q is greater than 10. And sometimes they even say equal to, and that's okay. Either around there. All right, so we know the conditions for proportions, or at least the 1 proportion z-test. What's the third step? Find the test statistic. Okay, so what is that? This test statistic will vary depending on the kind of test that you want or that you need, okay? For us, it's a z. It's a z value because we're doing a z test, okay? So here we're looking for a z, okay? Oh, sorry. All right, fourth step, p-value. Okay. What is a p-value? And this is important because I often, and AP often asks you to interpret a p-value. Oh, baby? Oh, really?
He always brings you up when you do it.
I know, because we...
I've been in bio for 2 years and I'm still trying to figure out the importance of the t-test.
Okay, well, we haven't done T yet. We're doing Z. We're going to do T. T goes with means. And that's our next unit. So we'll get to means. You'll get there. Huh?
That's the next thing because my brother's been asking me what it asking me that t-test.
T-test comes next. We're still doing Z's, but we'll do T's. Give me a week. All right? All right. Got recorded. Okay, cool. P-value is the probability. Can't really spell probability. Did I spell that right? Well, probability that the sample happened by chance. Would we want a small p-value or a large p-value? Small, very small. We want the likelihood that our sample happened randomly, happened by chance, to be pretty small. We want the results to be meaningful. So therefore, the lower, the smaller p-value you have, the more evidence you have to support the claim. I'm sorry, to support your alternative hypothesis. Okay? So I'm going to write that down because it's kind of important. The smaller, and I'm even going to say specifically how small. Oftentimes, remember with confidence intervals, we had like 95% confident or we had 99% confident. Those confidence level correspond to something called an alpha level with hypothesis tests. So we usually say that 0.05 alpha is corresponds to a 95% confidence interval, and an alpha of 0.01 would correspond to a 99% confidence interval. They usually are complements of each other. But you're really going to be comparing your p-value to an alpha. Okay? So if you have an alpha of 0.05, which is a common one that we use, because 95% confidence is often what we use as well. But if our p-value is smaller than that, or smaller than whatever stated alpha level is, then we have evidence to support the alternative hypothesis. Now, I'm going to write this down and then I'm going to cross it out. And I want you to do the same. So write it down and get ready to cross it out. We never say we support the alternative. And this is what bio does that they shouldn't do. Okay? So, in statistics, thank you. So, what we have to say is we either are going to reject the null, which is what we would do here, or we're going to fail to reject the null. Those are the only two options for a conclusion. We don't say we support the alternative, but if we reject the null, then we really are supporting the alternative. It's kind of just a play on words, okay? But they are very picky about the wording in AP Stats.
Oh my gosh.
Okay? So I'm just letting you know. So this would be the conclusion, actually, is the words reject the null or fail to reject. And then you would have to put it in context. So the conclusion is going to be those words along with the context. Okay? So what I'd like us to do is go ahead and try our first example based on the confidence intervals we created for our conversation hearts last class. Can we do that? So get out your data, and let's kind of compile it, and let's start with some information. Okay, so we have the conversation hearts from last class. First step, what's the test? I would even, in the beginning, let's number our steps. 1, 2, 3, 4, 5. I want you to do that from here until the end of the course, and end of this particular unit, to get us into the habit of remembering all 5 steps. Okay? Step 1, state the test. What is it? It's the only one we know right now. 1 proportion z-test. Now it says to state the hypotheses. So I need to be clear about what the hypotheses in a 1 proportion z-test are. The null hypothesis is always the claim. Businesses, companies, whatever the claim is, that's what the null hypothesis is always going to be. So what did I claim last class? What was the percentage I claimed? 10%. So we're going to write it numerically and in context. We think, by the way, it shouldn't be an equals here, it should be a colon. The null hypothesis is, the alternative is. We claim the true proportion of candy hearts is 0.1. That's the claim. And so we'll come back to, let's write that in context. What does that mean in context? The true proportion of candy hearts is 10%. Of pink candy hearts, sorry. Something else that's really important to take note of. The hypotheses are always, always, always written in terms of not the statistic, but the parameter, okay? So with P for proportions, for mu with means, it's the population parameter. The true population proportion is what we're trying to find, okay? Now, our alternative, what did I think was happening with the candy hearts? More or less? I can't remember. What did I think? Less? Okay, less. Because I think there weren't that many, right? So our alternative is either going to be a greater than, less than, or not equal to. Those are our choices. I think we said less than. Okay? The alternative hypothesis is the true proportion or the parameter of pink candy hearts is less than 10%. Okay? So when it comes to hypotheses, 2 things to remember. 1, always written in terms of the parameter. 2, the null is always the claim. And then the third one is whatever you're trying to prove, greater than, less than, or not equal to. Today we're only going to do less than. We won't get to a not equal to until I don't think until next class. We'll have to see. Actually, it would be next week because I'm not going to be here Friday. I'm going to the old folks home on Friday. Have I told you all about that yet? All right, so what's the second step? Done the first step. State the conditions. And didn't we do that before with the conversation hearts? I think we already checked them last time. Okay, so they were random. Don't ever do this. Random sample, yes. Whatever the amount was, I forget how many total candy hearts we had. Did we know that? I don't know. we'll just say however many candy hearts. Our sample was less than 10% of all candy hearts. Yeah, that was the issue. The NP was not greater than 10, was it? Right? It wasn't big enough, so we said proceed with caution, right? Percent of all candy hearts. And then NP was not greater than 10, so we had to proceed with caution. Again, I don't have those numbers, but you would put the numbers in, right? All right. Step 3. Well, now, what does it say we have to do? Find our test statistic. Well, we know it's a z-value, okay? So let's figure out some numbers. I think we're going to have to collect it. Let's use, can you guys look at your data and tell me how many, we need to find our p and our p hat, don't we, as a group, right? So let's tell me, let's create some information here. So can everybody maybe write the number of pink over here, and just one per table, right? And then the total over here. And we'll just collect it together and create one big sample. Is that okay with you guys? Okay, so come on up and do that. So for our sake, let's just find a total sample size. So we're going to add these up. And again, Amanda asked a great question. You rarely, if ever, are going to do this step, because you'll be told in the problem what your sample size was. So our bag had 421 candy hearts. And how many pink ones did we have total? Let's see. We had 48 pink candy hearts. So what is that number? P hat. Good. Okay, 48 over 421. Since we're trying to find a z-score, let's draw a normal curve. What's going to go in the middle of our normal curve? The claim. What's the claim? 0.1. The claim means that the average is 10%. That's the claim. Okay? Now, our sample, I'm not sure what that is as a decimal, 48 over 421. Not too far off, right? 11.11. You with me? Okay. And the alternative hypothesis tells you which direction to shade. We think it's less than that. Yeah. We think it's less than. That means less than, right? Less than 10%? Less than. So I'm going to shade less than this. Right away, what do you notice? Okay. Now, what we're finding is the p-value, and the p-value corresponds to our sample. All the hypothesis tells me is the direction, not with respect to. It's always with respect. The 0.1 is always your middle. You're going to put your p hat on wherever it goes into compared to 0.1. 0.11 is to the right of it, and then it tells me less than, so it's less than our sample. Remember, what a p-value is telling us is the probability our sample happened by chance. What other information are we going to need here? So we're going to find this. It's normal CDF, lower bound, upper bound, mean. Why did I leave the last number blank? Because we don't know it yet. Can we find it? Don't we have a formula for it? Right? I think we do. Okay, so what do we put in here? Why am I using different numbers than what you told me? Well, the claim is 0.1. Isn't P 0.1?
Oh.
Right? So we have a P, don't we?
That's all.
So we're going to use it. We only use the P hat if we don't have a P, which we have, so we're good.
Then what do you use standard?
Oh, it's standard deviation. Thank you, thank you, thank you. Yes. Thank you. Let's actually use the correct notation. I don't know what that is off the top of my head, but we'll find it. I'm surprised no one said anything, because we're skipping a step, but that's okay. Maybe you don't recognize it yet. 421. So this is 0.0146. Okay? So over here, we're going to put 0.0146. If I actually find the normal CDF here, what am I finding? This is actually the p-value. This is the p-value. This is the probability that our sample happened by chance. So what we're finding here is the p-value. We kind of skipped step 3. We'll go back and get that in a minute. So normal CDF, lower bound, upper bound, mean, and then the standard deviation, 0.0146. Paste. Before I hit enter, do you expect this to be what kind of a number? Look at the shading on the graph. What kind of a number? Bigger than 50. Would you agree? Bigger than 50%? Because more than half the graph is shaded? Okay. So is that what I want for a p-value? No. So the p-value I got here is 0.7533. Ooh. Okay. Well, we need to compare that to, for step 5, I'm trying to write them in color here. I'm going to compare my p-value to what? What did I tell you compare it to? What kind of a confidence interval did we create last time? 95%? 90%? I don't know. Which one did we do? I think we did 95, didn't we? So we're going to compare our alpha to 0.05, because alpha is 0.05. If we have a 95% confidence interval, our alpha is 0.05. They have to add to be 1. Since this is true, which one of my two conclusions do I make? Do I reject the null, or do I fail to reject the null? I want to reject it, because I want to prove it wrong. But I can only do that if the probability is really small. Since the probability is really big, what am I doing? Nothing. I can't reject anything. Darn. So I fail to reject the null, which means in context, I do not have any evidence to suggest that they were wrong. There really is a 10% of pink candy hearts, M&M, or M&M, pink candy hearts. Okay, I can't reject it. So the claim of 10% pink candy hearts we can't say it's true, but we can say that we don't have evidence to suggest that it's wrong, right? They're so particular about the kind of answer you can give. Let's say we cannot disprove it. We fail to reject it. We can say they always like to say we don't have evidence to suggest it's wrong. Have evidence to overturn it. Nope, we don't accept nothing. Don't accept that. Get it? Okay. Pink candy hearts is false. We don't have evidence to say that it's false. Okay? It's kind of like a double negative in a way. Drives me nuts. But that's the way we have to do it. Okay? So, let's make sure we know our step. Oh, we skipped step 3, didn't we? I went right to the p-value. So what do you think is meant by a test statistic? Well, I told you before what it was. What's a test statistic? And a one proportion z-test. What did I tell you it was? A test statistic was a z, right? It's a z-score. So what you need to do for the test statistic is you need to figure out what z-score that corresponds to. Okay? So our test statistic for the z is 0.11 minus 0.1 divided by, what's our z-score formula, by the way? X minus mu over standard deviation. So what is our standard deviation? 0.0146? Yes, sir. You can't just do that. You have to, this is standardizing it by putting in. Let me go back to your question. What did you mean by when you said that? Because there is something sort of. So this is a normal curve, right? We're trying to find the z-score that corresponds to our p hat. And there's another way, rather than comparing p to alpha, the p-value to alpha, we can compare that z-score to something too and get the same result. So the test statistic is just that. And I'm going to show you on the calculator how to find it too, but we need to find that number. I often skip it because we don't need it. That's why I did it here, because you can get the conclusion without it. We did, right? We already know that with the p-value so high, we can't do anything. But we should, that AP likes us to create this test statistic. So let's do that real quick. So up here, we already know it's a positive number because it's bigger than, right? We already know it's something. Let's see. So it is 0.11 minus 0.1 divided by 0.0146. 0.645. I'm sorry, I can't read. 685. There we go. We expected it to be a positive number, right? Okay. Now, we can compare the z with the z star, and we can get the same result. Okay? But I'll explain that another day. It's too much in one day. It's less than 0.95, therefore we'd also fail to reject. But it's okay to not understand what that means right now. Let's just, for our purposes, let's just find the test statistic and base our conclusion off of our p-value. We'll come back to what we would use that for. So we are definitely. Yeah, this is not the only one. Now, think back to what we did last class. Every single one of our confidence intervals did what? Every single one of them did what? They captured what? Judith! Wake up, darling. I know. It captured 0.1, didn't it? Every single one of them. So doesn't that kind of make sense that we couldn't prove it wrong? You weren't even here and you know that. I know. Brian! Wake up, baby. I'm even giving you sugar. I played music today. Y'all be tired. All right, let's look at another example. Okay. Oops. Da-da-dum. Oh, hang on. Nah, I don't like that one. Dun-dun-dun. Okay, smoke detectors. Let's look at this example. Okay? So, I want us from beginning to end to do all 5 steps of this problem. We can do it, right, Monica? I can do it. I think so. Let's at least have you write the null and alternative hypotheses down. Can you do that part? Just the null and alternative hypotheses. Do that part. So this is the claim, and the word at least, don't let that get to you. Your null hypothesis is always in equals, okay? Period. The claim is 90%. The alternative here is going to be above. We think we might have raised it above. So the alternative is going to be p is greater than 0.9. Okay? So step 1, we're going to do a one proportion z-test. That's all we know how to do right now. Our null, P is equal to 0.9. Our alternative, P is greater than 0.9. You must put context with it. That alone will only get you half credit on your hypotheses. Okay? You must put context with it. So what's the context? Jasmine, give me the context for part A. Point 0.9 is fine. Either one. Okay? Yes, ma'am.
Wouldn't that make sense? Say a portion of homes with one smoke detector then?
I like that even better.
Yeah,
Okay? I like that even better because she said, in context, proportion of homes with at least one smoke detector. You've included that up top. Nice. Okay, good. What's my alternative going to be? The true proportion of smoke detectors is greater than 90%. Our campaign worked, in other words, right? We made more people have at least one smoke detector in their house. So, can you kind of see this question? Do we have evidence that the local rate is higher than the national rate? So in other words, did our campaign that we had, a public safety campaign, did it work? That's another way to ask the question, right? Did it work? And we're going to do a hypothesis test to see. What's step 2? The conditions. Let's check them. I'm going to pause the recording. I want you to check them. Use the context, use the numbers in the problem. We should probably say that we have to assume that there are more than 4,000 homes in the town. Would you agree? So we're going to assume that so it satisfies that condition. I don't think it says that here. So we would have to do that. Did you have a question, Sean? Are you sure?
Yeah.
Okay. All right, so we should probably say that. Well, now, it does say specifically that the sample was randomly selected, so we know that it was the sample was collected randomly. It states it in the problem. Number 2 is what Charles was asking about, the 10% condition. We're going to assume that 400 is less than 10% of all homes in the town. So we would have to assume that it's at least a 4,000 home town, okay? So it could have been Manassas, right? All right, and then we need to be specific about step 3. Let's put some numbers in. NP is greater than 10, and NQ is greater than 10. Am I given an N and a P? Yeah. So we have 0.9 as our P, and we have, what is our N? 400. Good. So I have 400 times 0.9. What's 90% of 400? 360. Definitely bigger than 10. And then NQ is 400 times 0.1. So what's 10% of 400? 40. Also bigger than 10. So it satisfies all of our conditions. Woohoo! We don't have to proceed with caution. Yay! 2 thumbs up. All right. Step 3. Well, let's find the z-score first. I like to draw, though. I'm a fan of pictures. We know we have 0.9 as our claim, right? What's our p-hat? How many in the problem actually had it out of our sample of 400? 376, right? So our p-hat is 376 over 400. All right, let's, 0.94, thank you. In this case, our alternative hypothesis tells us the direction. We want it to be greater, right? So we're going to shade to the right this time of 0.94. Now, what z-score corresponds to 0.94? Well, 0.94 minus 0.9 divided by, got to find your standard deviation too, okay? And a 1.5. So 0.94 minus 0.9, 0.15. So our z-score is 2.6 repeating. Why did I say ooh when I said that? Is it a big z-score or a small z-score? Pretty big. Within 3 though, right? About 3 above, 3 below. So it's not unreasonable. But if I got a really, really big z-score, that would be some clues to us if something was happening. All right. And again, next class that I'm back, I'll explain what we do with that number. But for now, let's go ahead and find our p-value. We've gone ahead and drawn it. So how do I find it? Normal CDF. Lower bound. Upper bound. Mean. And standard deviation. Well, approximately. Okay. Let's figure out what that is. .004. In the context of this problem, what does that p-value represent? Who wants to say it for the class? Anybody want to take a venture? What does that p-value represent? Say it louder, Amanda. Probability that what happened by chance. Let's put it in the context of our problem. That 376 homes just was by chance, was by luck. Okay? We got lucky. Well, the likelihood that that was just a lucky venture is really small. Do you agree? So the likelihood that that happened by chance is really small, which is a good thing, which means that our sample was conclusive, wasn't it? Which means that we can do what? Reject the null, and we have evidence to support that their campaign worked, right? So that's what we're going to say. So we're going to say, for step 5, that because our p-value was less than our alpha, in other words, 0.004 was less than 0.05, we can reject the null, and we have evidence to say that. Now let's go back up to the exact wording. The exact wording was, the local rate is higher than the national rate. So let's use it exactly like what they say in the problem, okay? So we have evidence to say that the local rate is higher than the national rate. The campaign worked. We've gone through 2 now, from beginning to end. How do you guys feel? Okay? So we just have to think about it. I'm going to give you a couple to do that are in the book. I'm only going to give you odd problems so you can check your answers, okay? Since I won't be here on Friday. Odd problems only. But what do you think I'm going to ask you to do? Show work, okay? So that just means that, and would it be beneficial, I'm trying to figure out if I give you a complete, maybe if I would do one of them, a complete solution from beginning to end, maybe I'll post it on my door or something. They won't let me do that because they are mad about paper now on the door. I had to take my sign down on my door. I don't know, because it's more flammable than the door. What? Don't know. Don't know. Everything I do is wrong. I don't know. The snowflakes had to go. Everything had to go. Whatever. I want to give you one problem worked from beginning to end so you can check to make sure you're doing it right. So maybe next to the door, in an envelope, I'll put some copies of a worked out problem so you can check your answer. Does that seem reasonable? Or would you rather me just post it online? Post it online. I'll do that because that'll be within fire code. All right, good. So what's your homework? Okay. I think it would be beneficial to read chapter 20. Okay. And I'm just going to give you a couple of problems to look at. How are we doing? Only 19 and 20. Okay. So the quiz is on chapter 19 and 20, and what it's going to be essentially is, can you, given a context situation, can you create a confidence interval? Can you interpret the confidence interval? Can you find sample size like we did for your homework? Can you find margin of error, whatever? All the homework from last class, okay? And the other one is you're going to have to do one hypothesis test. Now, for you, on the quiz, don't just say, conduct the test. I actually break it down. And I say, okay, what is the alternative in the null hypothesis? What is the z? What is the standard deviation? What is the p-value? Draw the normal curve. Like I break down the steps for you on the quiz. You're welcome. I won't do that on the test, okay? But you have to do a hypothesis test. And each little piece counts as some information, okay? And there's one of each, and then there's a couple other little questions you have to answer. It does count 40 points, so it's kind of it's a big one, okay? All right, so let me pick a couple of problems here from chapter 20 that would be good. All right, I think 24 looks good. No, I'm going to put them out of order because I started at the back. I apologize. 24 is not an even. It's not an odd one. Sorry, I won't do that one. Because maybe you know what? That's the one I'll work out from beginning to end. All right. So you try 24 on your own, but I will do 24 also, and I'll post it online. But don't copy it without trying it on your own first, Hunter. Okay. All right. Let's do 19 and 21. Ooh, no, 19's a two tail. We can't do that one yet. Let's do 20, 21, and 23. Okay? Those are the three. 2 odds you do on your own, okay? And then I will provide a solution for that. Now, I'm only giving you 3 problems because they're long. Do you agree? Okay, from beginning to end. And you have some studying to do as well. So you have a lot of stuff to do. And I do really want you to read chapter 20. Fair enough? Okay.